สวัสดีครับ Good morning นะครับ everyone. And today I have a privilege presenting a project named Optimizing Quantum-Inspired Computational Technique for QUBO Problem Solving. And this is a project that we have helped research, and I think it will be significantly useful for in the industrial sector. And okay, before we delve into project detail, I would like to take a moment to introduce our dedicated team that's being our work to present to everyone today. And okay, let's begin with the member. Alongside me is my dedicated colleague, Muhammad, and we work under the insightful guidance of supportive Ajahn Rajwit Cup. And as for me, I have been receiving additional support from QTFT, which provide me a motivation and some esteemed guidance by Ajahn Warapong, Ajahn Sipanat, แล้วก็ Ajahn Thiramet ครับผม Okay ครับ next slide ครับ So here is an outline. So let's begin with an overview to the presentation. I will commence by discussing the genesis and significance of our topics. Following that, I will provide you some insight to our research effort and preparation for this project proposal, like what I have done previous month. And we also delve into hypothesis and idea guiding our experiment, and I will share our plan and session two, highlighting what department can expect from us ครับ Okay ครับ next slide. Okay. Let's begin by tracing the roots of our topic นะครับ QTFT is a Thai startup company that does some optimization work for their client using both classical and quantum techniques. And one of the popular quantum technique in this field is QUBO ครับ So it's popular because if we can convert any problem into QUBO format, we can run them on quantum-inspired computer or even real quantum computer. And this connection is arrived from inherent similarity between the physics problems encapsulated with QUBO ครับ because in physics problem, QUBO is similar to the problem of minimizing ground state energy of a system, and therefore that's why QUBO is well suited for quantum computing. And as we have some of we have heard that in the future quantum may can conquer classical computers. I think it's a good time for us to pay attention to this problem. And okay, so let's take a look at our topic, our problems, or in real industry. The uh, previous slide, please. Okay, in real world industry, even more data and more complex problem that we tackle, the more intertwined and challenging QUBO problem this become. So that make our nature of QUBO type problem has been go more intricate, and that's caused the connection between decision variable become increasingly messy. And in practical term, we can translate that into a metric of QUBO being very denser, or because the problem is more difficult. And as the result that when we are solving this problem today, it requires significant investment of time and resources ครับ So it led us the idea that if we could expedite this calculation, it could significantly expand our capability to tackle even more challenging problems. However, we may need to consider something, or we may need to carefully weigh whether it might be some trade-off or potential cost that associated with this acceleration ครับ Okay, next slide, please. Okay, so let me summarize our motivation. We have been inspired by a simple yet powerful idea to making QUBO calculations faster. And by achieving this, we aim to enhance ability to deliver a solution to our customer more rapidly and with higher quality, potentially addressing more intricate challenges. And we believe our work have meaningful impact on industry, so we can make processes more efficient and make problem solving process more effective. Go ahead,ครับ. So now let's take a look at the definition and some background of QUBO problem. QUBO stands for quadratic unconstrained binary optimization. It is essentially a mathematical model that we work with a binary variable that multiply together. So that's why it's called quadratic. And our goal is to discover the optimal solution for those equations. And when you have any equation involve multiplication of two decision variable or two variable, it can be represented as a n by n metric. So yeah, we can apply this approach to scenario like we want to maximize a company profit, or we want to minimize a cost equation. in various production. And as I mentioned before, the problem is suitable for running in quantum computer, which I think is a trend that will become in the future. And so we envision that quantum can be used in various fields, increasing it can increase efficiency in various processes, like in the business sector, such decision making. And so I think our project is intricately linked to this concept and can be viewed as some building block of realm of quantum computing. Okay, next slide, please. So here what I have done in the previous couple of months, and what I have presented here is about literature review. And here are 7 research examples that I think serve as a guideline for our research experimental further. And I would like to tell you that what subject that we have studied in the past month. And so let's start with the first paper. We have delved into the definition and format of QUBO problem. And second and third paper, second and third paper is provided some insight to art of translating well-known catalog problem into QUBO format. And for example, card coloring problem or traveling salesperson problem. So we have this study on that topic, and in study of 4 and 5 paper, we aim to exploring a diverse method for reduce problem size, which serve as a foundation ideas for our hypothesis. And I think this tag a general method for reducing problem size that use some mathematical way, and some people in data mining field are using it today. But our goal is to adapt this technique into QUBO format or QUBO problem that we have encountered. And the last 6 and 7 paper is the application of QUBO problem with quantum algorithm and quantum circuit. And that's providing us valuable insight that I think it can enhance utility of our works. But and also the 7th paper is about quantum enabling efficiency. And so okay, I must claim that we will focus on our original scope to make QUBO faster. But this study is try to give us some ideas, or we exploring this because we want to satisfy our personal need in learning. And okay, next I would give this stage to my friend to present next segment of our work.
Okay, so as Pantihi have said in the aforementioned slide that we have. Okay, sorry. Okay, as Pantihi has explained in the aforementioned slide that we have studied about like many things from the foundation of the QUBO to the application on the quantum computing platform. So I would like to tell you that our highly interested topic is trying to reduce the problem size by metric specification, because we generally accept that if we try to make the graph or metrics more sparse, it means that our problem will be like reducing size, but is it reducing complexity? This is still arguable, and is lead to our hypothesis that if we can reducing size by specification, can we reduce the complexity to like lead to the better performance in the computation too? So yes, this is our goal of this project is we highly focus on the metric specification using many techniques. And this is our experiments that we will try to like solve the QUBO with many reduction technique, mostly on focus on the metric specification like edge sampling or graph graph approximation and so on, and then we will be benchmarked, but we haven't decided yet which like we have to make a further research on the benchmark too. So like this is our experiment to lead to the hypothesis that it is have a better time complexity or not. And here's our scope of work. As you can see here, we try to like form our own algorithm from the mathematical equation and design to like just making the algorithm that for problem pre-processing. And in the second semester, if we have an opportunity, we will be try to running it on the quantum computing platform. This is our presentation. If you have any question, please don't hesitate to ask.
สวัสดีค่ะ Okay, I have some questions.
Yes.
Like I'm not clear about your scope of work. What is your scope? What are you trying to do? Can you go back to the slide?
In the slide, we didn't provide much about the in the technical term, but I have the backup slide that I have. Like this is we focus on the two problem, that is the max cut problem and the traveling salesman, which now we currently studying on max cut because it's like has less complexity than the TSP problem due to it is more simple, and we try to start from the simple thing. So yes, we try to like formulate the max cut to the QUBO format and try to optimize the metrics in the first half. And yes.
Okay,ครับ. Let me elaborate on more. So the question is what is the scope of our work? So we are trying to make some optimization, or specifically QUBO problem run faster in terms of processing and computational time. So what we are going to do is we explore some auto technique, like a mathematical way to find that is it worth to do it. So if the calculation is faster, but it has some trade-off, like the solution is not optimal, or solution that feasibility is disappear. So this is what we are going to study, how to make QUBO problem run faster with efficient and efficient solution.
Okay, I see. Okay, thank you. My next question is like the QUBO, like there is a slide saying that it's unconstrained binary optimization, something, right?
Yes.
So that means the problem optimization cannot have constraints. Is that right?
Actually.
Okay. Let me answer you first,นะครับ, and I will let my friend talk a little bit. So if it has some constraint, we have some penalty term in the objective function, and so we can add some linear constraint apart from our objective function. So okay, let me summarize my answers. If some problem have some penalty, right? We can have some term add to this to sigma, like we want to subtract from something is a constraint. So we can add this into our objective function. And
Okay, I see. So that next question, with this approach, is it guarantee for the optimum solution?
Which approach?
The QUBO,
Oh,
QUBO.
Okay, so as I have researched, it might not reach the like most optimal solution, but mostly they try to formulate QUBO to like find a sufficient solution.
okay.
You get me?
Actually, if okay, I think what he means. Actually, it leads to optimal solution, but the problem that we encounter is when the problem is much more have higher complexity, the optimal solution is come really slow. So we want to make it come faster, but our approach it may not lead to optimal solution. But even feasible solution is acceptable if the for example, if you want some optimal solution, but use some 2 hours, 2 hours to get that solution, it may not be efficient, right? But if you can run on five seconds, but get some feasible, but not optimal, I think it's also good
Okay, so
to use
let
it.
me summarize what you said. You said that the QUBO can offer or guarantee the optimum solution. However,
Yes,
it might take long time for a large problem
yes,
size,
Yes.
so that
exactly.
your objective is to reduce the computation time. However, the solution quality might have to be sacrificed
Yes.
to
Yeah, exactly.
be could be right. So that's your approach.
Yes, you're right, ครับอาจารย์
Okay, and then a little bit more. My last question: what is your approach to make it faster?
Oh, okay. And as I said before, when we have some when 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 we have research on some when we have encounter on some complex problem or even large problem, the data is more intertwined in terms of it when we represent in metric is our metric is very dense. So so to address your question, our approach is to make metric more sparse. That means we may disregard some term in our objective function, but which term we don't know. We have to study. Maybe some term is have different weight or uh, different value in for this problem that we are going to study.
Yes. So
Okay,
yes, it's like that. We try to like reduce the problem, but still keep the characteristic, some important characteristic of the problem, to like still give the feasible solution.
okay, thank you. Then the next, maybe another question. So how
Yeah.
are you going to evaluate your results?
I think we for now what we can think about is two matrices. First is processes time before we are going to solve some optimization problem, and the last the second one is some value of the optimal solution. So for example, it's a minimized problem. I think it should satisfy every constraint, but is the number is low enough for using it or not. Did I answer your question?
Okay, all right, thank you.
Okay.
What is your quantum hardware that you are going to use in this experiment?
Okay, let my friend answer นะครับ
Uh,
อ้าว
so
แบ่งกันตอบอาจารย์
at the start of our research, we using D wave. If I remember correctly, we might use D wave 2000Q. Yes, if I remember correctly, because like when we're trying on the Qiskit platform, we found that if we like set the node to like nearly 100, something like 60 nodes, and it cannot run, like it can't run at all. So yes, we will focus on the what is called D-Wave maybe 2000Q. Yes.
You look so tired.
Yes.
Do you think you can finish this topic on time? Okay, just kidding. Okay, I have no more questions. I think all the questions that I would like to know, Ajahn Naramon has already asked. Maybe let me see your progress in the next time presentation. Thank you.
Thank you.
thank you ครับอาจารย์
I don't have a question because we talked before, but then I just want to like remind you guys one thing, that this is the research question. Like it's not like the other senior project that they implement application or something else. So like I told you guys before, that I'm not quite sure that if you reduce the specificity and all the metric that you guys think will be better, because maybe not, right? So is this the hypothesis? You guys just want to prove the hypothesis, because from the motivation on page 5, I think I saw that you guys said that like you want to make it faster and better and quicker than before. So I'm not quite sure about that. So don't overclaim it.
Yes.
Okay, that's it for me. Thank you.
Thank you ครับ
thank you ครับ
ครับขอบคุณทุกท่านมากขอบคุณ Mentor Supervisor ทาง QTFT ด้วยนะครับวันนี้นักศึกษาสามารถจัดการเองได้หมดเลยขอบคุณครับ
well done
ครับ
ครับ
ขอบ
ผม
คุณนะครับ
ครับขอบคุณมากครับ อันนี้ผมหยุดแชร์จอได้เลยใช่ไหมครับ
ได้เลยครับ ทีนี้กลุ่มต่อไปนะครับมีอาจารย์ที่เป็น
ครับ
คอม
สวั
มิ
สดี
ตี้
ครับ
สวัสดีครับสวัสดีครับ
สวัสดี
ส
ค
วั
รั
สดี
บ
ครับ
ครับต้องแจ้งอาจารย์คอมมิตี้กลุ่มต่อไปก่อนว่ากลุ่มต่อไปเขาขอยกเลิกการนำเสนอครับเขาจะเปลี่ยนหัวข้อแล้วเขาไม่อยู่ที่นี่แล้ว ก็เลยผมต้องอยู่รอบอกอาจารย์ท่านอื่นที่เป็นคอมมิตี้ด้วยตอนนี้มีคอมมิตี้อยู่อาจารย์ณัฐชากับอาจารย์ธำรงรัตน์อยู่ตรงนี้แล้วต้องขอโทษด้วยนะครับ กลุ่มนี้เขา
อาจารย์
ขอ
ครับ
เลิกการพรีเซนต์
ของเดิมคือเบอร์กลุ่มอะไร